I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 17th. Tonight we'll be talking about jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making big waves in the North Pacific Ocean. We'll also take a quick look at precipitation potential and snow for the western United States. Let's get to work. Looking at significant wave heights, we see a developing gale in the western Pacific with 31-foot seas building, moving its way towards the dateline. A smaller gale over in the northwestern Gulf, not doing a whole lot. And otherwise, pretty calm pattern. That's just the beginning, though. A fair number of gales are forecast over the coming week. First up, we like to look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a dip in the jet, just like here. That's called a trough. And a trough helps form a counterclockwise flow aloft and also down at the ocean surface. And that, of course, is the sign of low pressure. Low pressure generates wind. Winds generate seas. That is, it roughs up the ocean surface. As those seas build, they radiate away from the fetch area and eventually turn into swell. And swell, when it hits your beach, turns into surf. So, of course, we're very interested in troughs. All right, so we see a trough developing here. This is Sunday evening. Approaching the dateline, a fair amount of winds. The more wind energy pushing down into the trough, the harder it helps, more it feeds energy into developing low pressure systems. So we have, what is that, 1, 2, 3, 4, what is that, about almost 170 knot winds. Not super strong, but reasonably decent. Now as we get into Monday night, we see building winds over a larger area helping to feed the trough. That should, again, support gale formation. And then the trough moves into the northwest Gulf of Alaska and starts moving north of the Aleutian Islands, not doing a whole lot. Notice this big ridge holding here over the Gulf of Alaska. A ridge does the exact opposite of a trough. It supports a clockwise flow, and that's the hallmark of high pressure. But also notice, as we get into Tuesday night, a new trough starts building, pushing down right over the U.S. West Coast, maybe providing a shot of some weather, mainly more inland at the coast, maybe a little bit of snow for the mountains. We'll have to look as we work our way into the presentation. You see that trough continuing into Wednesday. Good, healthy jet stream flow aloft, pushing off Japan over right just a little bit beyond the dateline. Winds at, 170 knots. New trough, broad trough building in the Northwest Pacific on Thursday, and then working its way over the dateline on Thursday night into Friday. Just a broad trough centered, about 38 north, something like that, and almost pushing high pressure out of the way off the U.S. West Coast, but not quite. So we're into Saturday. New small trough developing over the north dateline. It too starts pushing to the east, starts getting pinched off though. The ridge. So we have this trough. It's sort of a split pattern. There's a trough here off the U.S. West Coast, but also getting cut off to the north. Hard to say how that's going to play out. And then here we are at 180 hours out. Looks like the jet's starting to split and lift north. So we'll have to see how that plays out. But for the time being, things are looking pretty good for the next week over the North Pacific Ocean. Next up, surface level pressure, surface level winds. We see, of course, that developing gale in the trough. Now notice it's nearly filling the entire Northwest Pacific. That is the low pressure, these isobars here. But fetch-wise, only this one little pocket here was at 40-45 knot winds, imparting energy to the ocean's surface. This fetch here, all aimed to the north. Not of particular interest at the moment. So we get into Monday, the fetch continues, 35, 40, little pockets of 45 knots, not particularly impressive. Then finally on Monday, it all starts getting consolidated into one fetch, but also notice the core of the low, about 972 millibars over the northern dateline region. Still, building some fetch, broader area 45 knot fetch into Tuesday morning. That actually looks pretty decent, pretty respectable. And then by Tuesday evening, the whole system lifts north over Alaska, not doing a whole lot. But here comes yet another gale forecast. There we go. Wednesday or so, notice we have pretty good sized fetch of 40 knot winds. And that pushes over the dateline, sort of falls apart a little bit, lifting north, doing the same thing, rapidly moving into the, we'll say, the northwestern Gulf, and then by Friday, starting to fade out, and really nothing after that. Things looking kind of weak, and remember the jet stream was falling apart that time too. Now another low is trying to organize over Kamchatka. It's not doing too much, but then there's some hints of some local sort of a low developing in the Gulf. A week out, don't know that that's really believable. Something to sort of keep in the back of your mind. We're not betting on it, though. So what are the effect of those winds on the ocean surface, specifically seas? Now, we're actually going back to almost a week ago. Monday night, there was a solid gale, actually a storm that developed in the Gulf of Alaska with 39-foot seas, 41-foot seas. This is a system that produced swell that hit California on Friday time frame into Saturday and Sunday. That swell is fading out now. You can see this was as of Thursday. It was dissipating. Another system developed over the dateline on Thursday, falling southeast. That has targeted Hawaii. That swell has hit there as well. It hit starting on Saturday and then was fading out on Sunday. And now, here's where we are, present time, new gale developing in the western North Pacific. Moving forward, we see that gale building in coverage Sunday night up to, what is that, 33.5-foot seas? Okay, we're going to call it 32, maybe 33-foot seas. Yeah, one little tiny area higher, but you need broad areas of fetch and broad areas of seas to make meaningful swell. And that moves to the dateline with 34-foot seas mid to later Monday, then rebuilding some up here in the northwestern Gulf with, it says 39-foot seas. That's pretty solid, probably a little bit on the high side. We'll bet you we'll see 37 or so out of it. Pretty far to the north, certainly resulting in shadowed swell relative to the San Francisco Bay Area, but certainly swell for the whole U.S. West Coast, maybe even a little bit down into Southern California. That system moves off on Wednesday, starts petering out. New system builds behind it. Small area, 30-foot seas, 28-foot, kind of fragmented, not really coherent. Some small swell should result from that. And things kind of go quiet as we get into next weekend. Yeah, I mean, there's seas, but there's no, really, we're looking for 30-foot or higher. If you really want to stretch it, we'll say 28-foot seas or higher over a decent size area. Here we are, 180 hours out, that little system off of Kamchatka, barely 28-foot seas. Yeah, ripples from that, if it happens, might show up in Hawaii. Other systems, supposedly in the northern Gulf, we don't believe it. But, in general, a steady beat of fetch and swell looks likely for the coming week. We'll take a quick look at winds over the Hawaiian area and California area. Not so much even looking at wind swell anymore because it looks like there'll be plenty of swell, but just sort of get a sense of, well, are trades going to be blowing in the Hawaiian Islands, or are you going to get some sort of Kona wind, north wind mess? And the same thing relative to California. So we're into Monday. A little bit of northerly flow off of North California, but pretty light relative to Central California, San Francisco Bay Area. Trades for the Hawaiian Islands. We get into Tuesday. Now, here's where things get kind of hokey. There is that backdoor trough that we saw in the jet stream. Low pressure building inland. High pressure 1028 millibars over the Gulf. When you get low and high pressure next to each other, that amplifies winds between them. You get building 30-knot winds. 25, and then look at this as we're getting into Tuesday night, a building just mess of winds off of California while trades hold for Hawaii. 20, 25, 30 knots. We're not even at daylight. Here you go. At daylight, it's 30 to 35 knots off of Northern California. Yeah, near shore, it looks light. But with all this wind blowing, it's just going to be a tattered mess everywhere from at least, oh, even the fetch, look at that. The wind's even blowing into Southern California. Pretty much a mess on Wednesday. There'll be wind swell, but you'd have to find some very protected break. Good news is, by Thursday, that starts moderating a little bit, and by the time you get into Friday, hey, we're into a light wind pattern, and we know there's all kinds of activity going on, or previously had gone on over the dateline and into the northern Gulf, so this bodes reasonably well. Same deal as you get into Saturday, light winds, strong trades for the Hawaiian Islands, a solid 20 knot over the entire island chain. Saturday, light winds or offshore winds persist. Sunday, look at this new high pressure starting to take shape. I mean, this is this typical like La Nina kind of pattern where this time of year when you have high pressure anchored in the Gulf of Alaska, trades are above normal for Hawaii, and you get more north winds than you'd ever expect in Northern California. That it smells like La Nina, even though officially we're not in La Nina. And there you go, into Sunday evening. Look at this, Saturday afternoon, you got 15 knot winds or better over all the North and Central California, and by sunset, 20 knots up to 25 knots. Still solid trades for the Hawaiian Islands. And then you're into Sunday night, a week from now. Almost a summer-like fetch of northeast-east winds the whole way to the Hawaiian Islands. Sure, wind swell for the east shore of Hawaii, but we don't really care about that. What you really want is that northwesterly swell. Same thing relative to California. Low looking good on this zoomed-in picture here in the Gulf, but again, that's a week out. Don't believe it. All right, precipitation relative to only California here. We're looking for really any rain to stamp down or tramp down any fire potential, but also hoping for some snow. We see a weak low pushing into the Pacific Northwest on Monday night. It starts falling south. Remember, you have that gradient sort of thing, weak low pressure inland. Rain coming tantalizingly close to California, maybe a little bit on Wednesday, mainly for the Sierra, and a little bit of snow right there. You see that over the central southern Sierra sort of thing, and then pretty much out of the picture. We don't even think there's going to be, let's go back and just see any precipitation potential for the coast. Basically, no. Southern California, better than Central and Northern California. Okay, take that. Add insult to injury, right? Okay, low pressure hanging to the coast, then fading, waiting for some other hope. We're just blasting through the model here, looking. Weak fronts, nothing even really making it except maybe into the Oregon-California border. All precip north of the California state line for the most part. Quick look at snow. Now, this is it took us forever. We finally have a view of the Pacific Northwest with some site-specific accumulations like Crystal Mountain, Lake Louise, Revelstoke, Jackson Hole, Sun Valley, Big Sky. So you can watch the pattern here. You'll see the precipitation basically falling. We'll just roll this out. There's a little blast on Tuesday. Focusing more inland, you'll see that. And as we get here, you'll see snow accumulations. These are estimated snow accumulations for certain resorts. And then we get into Friday. So this is the 10-day GFS model. You can see it also, again, focusing Whistler, Revelstoke, Crystal Mountain, the Northwest more than, and then inland into Big Sky, that area. And then what do we got? Another one as we get into Tuesday. So looks like 3 systems on the charts. Okay, let's go take a look at the Southwest Pacific, and we'll just roll this out, and you'll see everything. There's the we'll call it the Sierra snow event, and somehow it all manages to get inland, but leave California high and dry. I mean, at least in terms of the coast. Okay. Snow mass, 9.4 inches, and this is as of 120 hours out. Taos, 8.1 inches. Badger Pass at Yosemite, 0 inches. You get the general idea here. We'll roll this out again. We'll keep going. Here comes another system. Same sort of deal happens. Focuses on Colorado, a little bit on Utah. Nothing for California. Oops, and that was it. Okay, so what was our totals there? 12 inches for Snowmass, 12 inches for Taos, and 5 inches for Mount Bachelor. Bear Mountain down in Southern California, 0.2 of an inch. Badger Pass, nothing. And just to rub it in a little bit, okay, Squaw Valley, here is the forecast. What's that? Maybe a trace for snow. That's over the 10-day, was that 240-hour window. Snow levels, so this is the top of Squaw, this is the base of Squaw. If it's red, it's above freezing. You see basically above freezing temperatures the entire 10-day time and wind here, but who cares if you have no snow? Who cares about the wind and any of that? We'll play the same game for Mammoth. What's that? Maybe 2 inches of snow, something like that. Snow levels, well, they are higher. Here's the top peak at Mammoth at about 11,000 feet. So you get some larger areas of below freezing temperatures, and then some wind associated mainly with the latter event. But again, not enough snow to really, get yourself too worked up over. So let's go take a look long-term what's going on with the Madden-Julian oscillation, that periodic oscillation that traverses the Pacific in 3-4 week duration. Active phase, that feeds the storm track, both in terms of snow and in terms of surf. And in the inactive phase, it feeds high pressure and basically shuts everything down. And then the longer-term outlook, what's going on with the El Nino Southern Oscillation? Are we heading towards El Nino? Are we heading towards La Nina? Or are we heading towards La Nada? So as usual, we'll start by looking at winds across the equatorial Pacific. So this is the West Pacific here. This is the East Pacific here. There's the equator. The date line, 180 degrees right there. We're just looking at the arrows. This is data from the TAO buoy array, series of buoys strung across the Pacific, used for monitoring El Nino, but also good for monitoring the MJO. These are 5-day average winds, so it's not real time. It's just kind of a generalized view of what's been going on the past 5 days. So winds out of the east, pretty strong. That's trades over the eastern Pacific, making its way across the central Pacific to the date line. And then notice westerly winds west of there, basically from just past the date line on over to 135 east. Now it's anomalies, the differences from normal for this time of year that really matters. In the East Pacific, yeah, the winds are strong out of the east, but you look at these little arrows, and we're only interested 5 degrees north and south of the equator. Pretty much normal. Same thing, maybe even a little bit westerly here south of Hawaii, and then stronger westerly, but not super strong, in the Kelvin wave generation area. What's that? Well, it's basically a fancy word for the far west Pacific, from 135 east to 170 west, 5 degrees north and south of the equator. You draw a box there. When you get westerly anomalies in there, and that's driven by the active phase of the MJO, remember we talked, there's 2 phases, active and inactive. When you get westerly anomalies, that helps fuel precipitation, that helps fuel energy transport up into the jet stream. When you have a strong jet stream, then you get troughs. When you have troughs, then you get storms. When you get storms, you get surf and you get snow. So that's what we're always interested in, is the active phase of the MJO. It's sort of like a mini 3-week El Nino, though that's a gross misrepresentation, but think of it like that in very broad brush strokes. All right, let's go take a look at the forecast for winds across the equatorial Pacific for the next week. All right, so here we go. This is the whole planet on one chart. This is zonal wind anomalies, the east-west component of the wind. I don't care whether the wind's blowing south or north. What I care about is it blowing harder out of the west than normal or harder out of the east than normal, and only in one small area of the planet, that Kelvin wave generation area. So this is the whole planet. 180 degrees is the date line. Okay, so that's in the Pacific Ocean. The Pacific extends from about 135 east from here to about 80 west, which would be Ecuador right there. But it's this one little area from, let's just imagine drawing a line from there to about there. That's the Kelvin wave generation area. All right, so from there to there, and we see yellows and that's outside of the Kelvin wave generation. So mainly yellows, weak westerly anomalies. And notice, going back in time to November 2nd, we've had steady westerly anomalies in the Kelvin wave generation area. That sure smells like the active phase of the MJO. So let's think about it for a minute. Well, what's been going on? Well, we noticed the jet stream's been getting a little bit more organized. We noticed the storm track has sort of woken up. It sort of smells like, hey, all of a sudden fall's here. And that started, about a week or so ago, somewhere around here, after the active phase had been going for about a week. So that all makes sense. It takes a little while. You just don't get the active phase and then instantly everything wakes up. It, takes 2 weeks of westerly anomalies in the Kelvin wave generation area to then get the jet stream reconfigured, impart a little bit of energy to it, and then get the swell producing machine going. So we're about right on track. Now, here's where we are today, light westerly anomalies, and the forecast is for that to continue till, looks about almost Thanksgiving. So that's not bad. Now, this is the interesting thing. Notice these strong easterly anomalies in the Indian Ocean. This has been going on for months. It's a separate oscillation. It's not El Nino. It's not La Nina, though it sort of looks like it would be a El Nino pattern. High pressure in the Indian Ocean, low pressure westerly anomalies in the Pacific. But no, it's not. And you'll see there's more to El Nino than just whether you have wind anomalies. There's also what's going on in the ocean. We'll get into all that in a minute. All right, so let's focus. More data on the MJO, please. Now things get a little weird. All right, outgoing long wave radiation. Fancy way of saying cloud cover, right? The active phase of the MJO is sort of like a mini El Nino, sort of like produces low pressure, produces cloud cover. Okay, so as of right now, let's see, there's South America, there's Central America, there is New Guinea, you get it, the equator right there, dateline right there. We see, and here is the area, the blue is negative anomalies, meaning less sunlight reflectivity off the ocean surface. This is, what's it called? Outgoing long wave radiation. Fancy way to say how much sunlight's bouncing off the ocean surface. If you have no clouds, you get a lot more sunlight, and that's what they're talking about here. And that means high pressure. That means the inactive phase, the MJO. So this looks like, according to the statistic model, that right now the active phase of the MJO is moving east from the dateline, and the inactive phase is setting up over the maritime continent, trying to move into the West Pacific. But it doesn't really do it until about 10 days out. Then finally the active phase of the MJO dies, inactive phase sets up. One would say, okay, that's the statistic model. The dynamic model right here, basically painting the same picture. But the good news is, where the statistic model says, we'll call it modestly strong inactive phase, 15 days out, the dynamic model says, weak and fading. That's the option I want. Phase diagrams, another way of monitoring the MJO. So what is this thing that I'm looking at? It's called a phase diagram chart. Assume you're looking down on the North Pole, and this is the equator running around out here. The MJO, active or inactive, moves from west to the east, from the Indian Ocean, over the maritime continent, like Bali, across the western Pacific, across the eastern Pacific, underneath the United States. Remember, it's only on the equator, across the equatorial Atlantic, over North Africa, back to the Indian Ocean. So where the heavy dot is right there, that's where the active phase is, according to this right now. It's like almost over North Africa in the far eastern Atlantic. And this is the forecast for the next 2 weeks. Basically, and the further it is away, the further the dot is away from this circle, the stronger it is. So we'll call this a weak active phase. If it was out here, it'd be strong. Over the far east Atlantic, forecast to move to the Indian Ocean. That's interesting, because it kind of, the other data we've seen says, well, the active phase is lingering still on the dateline, like back here somewhere. All right, that's from the statistic model. The dynamic model, saying basically the same thing initially, but with the active phase getting very weak and collapsing to nothing at all 2 weeks from now. Okay, upper level model. Let's go look at that. There's a 40-day view. It's not showing you the MJO. What it's really showing you is potential for precipitation. The oranges and reds are positive numbers, favorable for unfavorable for precipitation, dry, we'll call it that. The greens, negative, favorable for precipitation. So this suggests that the inactive phase of the MJO, just like what we saw in some of the other data, over the maritime continent, working its way into the West Pacific somewhere around Thanksgiving, and then quickly fading and dissipating while a modest active phase of the MJO sets up, pushing cleanly into the West Pacific about mid-December, and then working its way across the Pacific through Christmas and a little bit beyond. All right, so this sort of suggests that whatever pattern we're in, maybe we've got another week for it, for favorable for storm production in the Pacific, and then we go right back into the high-pressure funk for another 2 to 3 weeks maybe. And this model runs about a week ahead of what happens in reality. So today it's saying we're already losing our MJO, but the models are saying, well, there's still, some storms and activity to go. But a week from now, they say it shuts down. So this is all correlates pretty well and suggests that that's exactly how it's going to play out. Let's go look at one more model. All right, the 1 month CFS model. Again, this is east-west component of the wind. There's multiple components to the MJO. There's the wind component and the precipitation component, and there's probably a pressure component as well. Anyway, all right, so Kelvin wave generation area from about here to about here, going straight up the chart. Solid contours here represent the active phase of the MJO. The time runs, you can see, down here, so we get to mid-December. So, westerly anomalies, the reds and oranges, in the Kelvin wave generation area, active phase of the MJO in control today. It sort of fades apart, but westerly anomalies are to continue through, according to this, through Thanksgiving or so. That'd be good. So that would still mean reasonable favorability for storm production through Thanksgiving. And then the dotted contour is the inactive phase of the MJO. That sets up, start pushing across the Kelvin wave generation area into about mid-December or so. And then it looks like, well, it's hard to say. But of note, notice this massive area of easterly anomalies locked in the Indian Ocean. That has been the case all fall so far, and the expectation is that will continue for a while. That's sort of blocking the atmosphere a little bit and disrupting the normal flow of things. So the exact dynamics of what it does are kind of hard to say, but we think it actually kind of, because you have this easterly component, high pressure component locked in the Indian Ocean, it's actually blocking the flow of energy around the globe. It's sort of like everything stops up to the west of this blocking pattern, leaving very little energy to seep across into the Pacific Ocean. But that's just our guess. And then there's the 3-month CFS model. Now this time runs this direction. So there's today, there's the future. Kelvin wave generation area between about here and here going straight up. So here's where we are. The interesting thing about this is it's showing westerly anomalies in the Kelvin wave generation area, and they're supposed to hold the whole way into almost the end of January. That's the good news. The bad news is here's all that blocking easterly wind mess that's in the Indian Ocean. It's supposed to finally disintegrate. The blocking pattern finally breaks up, let's call it, say, early February, and then it floats across the Pacific and completely stomps on everything. Easterly anomalies in control. All right. The good news is, sure, it's out of the Indian Ocean, and it's not really establishing itself in the Pacific, but it's starting to flow east. That's good, but the problem is that's right in the heart of winter, and so basically it blocks all winter, all fall, and all January, and then in February it finally makes its move. By then, winter's over. You get March or so, and you have no recovery time. So, something to consider. All right, so let's overlay the MJO, see what effect. And look at this. We have, just eyeball this, literally no MJO pattern. The stronger the MJO pattern, the higher the propensity for storm production, especially if it's active phases of the MJO. So here's the solid contours is the active phase of the MJO. Here's the current one that we're in. It's supposed to go till right about like what we said, maybe right before Thanksgiving. Then the inactive phase, this dotted contour sets up, but it's not very strong at all, and westerly anomalies prevail in the heart of the Kelvin wave generation area. Then we go into a dead neutral MJO pattern with westerly anomalies holding. Now, you see these bits of active. I suspect there's more active going on here than what the model's saying. And then here come the easterly anomalies. Even though the active phase of the MJO is controlled, when you have an active phase of the MJO with easterly anomalies, that's not a good sign at all. It means that active phase is of no consequence whatsoever to help feeding the jet stream and storm production. So, not so good. Let's overlay the low-pass filter. All right, so this is a propensity, a bias towards low pressure, if you will, the solid contour. Right over the date line. That's exactly where you want it. This has been toggling on and off. There used to be a third contour that was supposed to develop in here. It's gone from the models and has been gone for a couple of weeks now. Suspect it's not coming back. And this is showing sign that even the low pressure bias is maybe supposed to start weakening as we get into March. That's typically when one would see the development of a strong La Nina or El Nino, is like in that February, March, April time frame. If it doesn't develop pretty strong by then, if it doesn't even start till the June, July, August time frame, then typically it'll be pretty weak. Right now, undetermined. We think we're actually in the warm phase of the PDO, and now we're going way down a rabbit hole, but basically the PDO is like a 15 to 30 year cycle that either sort of acts like an El Nino or acts like a La Nina. The good news is we think we're in the warm phase of the PDO, which is the phase that acts like El Nino. We started that in 2014, and so what that says is for the next 15 to 20 to 25 years, you know, generally the Pacific might set up to look more like an El Nino active MJO pattern and favor those over anything that's like La Nina or the inactive phase of the MJO. I mean, not a very exact science at all, but more than just a random theory, something to consider. All right, that said, let's move on from the MJO. Let's move into, let's talk a little bit about El Nino, La Nina. And so there is the MJO component of El Nino, which sort of looks like the active phase of the MJO. But there's also subsurface ocean temperatures that play a part in El Nino. Okay, so what are the temperatures doing today? Well, here's the West Pacific. Here's the East Pacific. This again from the TAO buoy array series of buoys strung across the equator. Well, only 2 degrees north and south of the equator. Over thousands of miles. Noah goes out and strung the buoys, anchored them in deep, deep, deep water. And then here's the anchor lines of those buoys. The little X's are the sensors on the anchor lines. And then all those sensors link up to the buoy that's sitting on the ocean surface. It has a solar panel and a transmitter on it that beams all the data up to a satellite that then beams it all down over somewhere in the northeast coast, Maryland, I think it is. They all assimilate that. They use a model to connect all the dots, and then you end up with a pretty picture that shows you what the temperatures are, not on the ocean's surface, but at depth, down 100 meters. That's like, 300 feet? 200 meters? It's really the top 150 meters that really matter. All right? 30-degree isotherm, that's 30 degrees centigrade. Warm water in the West Pacific here, hanging about where it was last week. The 29-degree isotherm, I think it's actually moving a little bit off to the east. The 28-degree isotherm at 153 west, that's a little bit off to the east too. And then the 24-degree isotherm, it's been locked at about 106 for a month now or more. It looks like warm water, gentle warm water, is pushing off to the east. Let's go take a look at anomalies, differences from normal for this time of year. So what's all that mean? Well, looks like the water's a little bit warmer in the West Pacific, 2 degrees, and it's actually growing, moving to the east. Not fast, but a little bit. So maybe that's a Kelvin wave. We haven't had a lot of, so what's a Kelvin wave? It's, why are we so interested in the MJO, the active phase of the MJO? Sure, it imparts energy to the jet stream. What it also does, those westerly anomalies take that warm water there, start pushing it to the east, but not at the surface, because remember, trades are blowing out of the east, nuking. It actually takes the warm water, pushes it to depth, and it pushes the whole way across the Pacific, hits the coast of Ecuador, erupts, and creates like a slick of warm water on the ocean surface. So what do we got? This is anomalies, differences from normal. We see what almost looks like a Kelvin wave trying to organize over in the West Pacific. But look at this, 3 degrees centigrade, that's, what is it, 1.8 degrees transition. So what is that? Not quite 6, but 5 degrees above normal temperature off of Ecuador. This is Kelvin wave number 5, pushing into the Ecuadorian coast, also reaching up to the surface some. The question is this guy actually moving to the west? Well, we don't know quite yet, but we got some ideas, and we have a chart that shows that. But before we do that, okay, here is yet another model of the same data. Here is Kelvin wave, I think we called it number 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 4 degrees centigrade, yeah, but generally 3 degrees centigrade here, Kelvin wave number 5, and we know this is pushing inland. This chart actually runs about a week behind the other chart. And then here's that other ball of warm water. We'd really want to see more of it seeping in over here. It's actually cooler water off here, so that's a little troubling. But the good news is warm water basically filling the whole 100 meters and up in the under the equatorial Pacific. So here's the trend, all right? This is upper ocean heat anomalies, the upper 300 meters of the ocean surface. We're going back in time. A year ago, November last year, Kelvin wave number, what was this, 3, pushing across. Remember, you get the active phase of the MJO, creates westerly anomalies. They start blowing warm water here off to the east. That was Kelvin wave number 3. Then in January, February, March, another Kelvin wave, a little bit stronger. Look at that. It made its way the whole way into Ecuador. Then this summer, we had 2, I wouldn't even call them Kelvin waves, just areas of warm water that moved nowhere. They just sat stationary in the central Pacific. And then we thought we had another one that started developing in the let's say August time frame, associated with the active phase of the MJO there. But then for whatever magical reason, it had enough push that it's actually working its way the whole way across the Pacific. Here's where we are today. It's within 400 miles of hitting Ecuador, okay? And of also some interest, look at this. Here's that warm temperature starting to build in the far West Pacific at depth, suggesting that yet maybe another small Kelvin wave is on its way. Now, if you were in La Nina, you would not see Kelvin waves making their way across the Pacific. If anything, you'd see cooler than normal, see like that, cooler than normal anomalies. That's what we thought we were getting in the summer, was La Nina developing. The atmosphere actually right now is acting like we're in La Nina, especially in regards to California, because there was cool water south of where California was on the equator. That is breaking up at the moment, but the atmosphere does not instantly respond to that. It takes months of a change. Okay, we had May, June, July, August, September of cool anomalies, and so it'll probably take 3 months before the atmosphere responds to this warming if it persists for multiple months. So it's a big boat, takes a long time to turn. That's the short message. All right, what's going on at the surface? Well, here is interesting. So here is Peru. There's Ecuador right there. There's the equator, right? We do see warming building off of Ecuador. We associated with the Kelvin wave. This is only surface level temperatures. So the warm water is all here, but down at depth. Some of it's peaking to the surface here, yet more of it's trying to erupt into Ecuador. So you get this generalized light warming pattern. But notice we have cooling off of Peru, cooler temperatures, cooler than normal. It's been off there, and really it was north of the equator most of the summer. That's why we say it seems like we're in La Nina we believe because of the cooler than normal water temperatures that were here. But warmer temperatures building somewhat. Most of it, though, focused more out towards the dateline. South of Hawaii, there's Hawaii there, and that region. And that's why we think most of the storm potential for this winter is going to be focused more out towards the dateline to the northwestern Gulf of Alaska, and not a whole lot pushing into California. And that includes precipitation, because temperatures have just been cool. They're only recently now, like literally within the past week, starting to rebound with any magnitude. Even that's pretty weak. So, again, not great for California's snow and precip potential. But what that also does mean, doesn't mean there's not precip coming into the U.S. West Coast. It just tends to push north. It ridges north. You have high pressure off of California. Drives the jet stream north. The focus is Washington, British Columbia, and inland of there. And that's exactly what we're seeing on the snow potential charts. You saw that. Everything pushing up into British Columbia, then falling down interior U.S. Locations. If you're going on a ski trip or you're planning on skiing, use that as your guide, at least for now. What is the trend? So these are not actual sea surface temperatures. It's just, is the ocean getting warmer or colder? You see it's getting warmer off of Peru and Ecuador, and little pockets out along the equator, and generalized warming in positions off of Peru. That's kind of a good thing, we think. Green is dead neutral. Anything that gets things warmer out here is better, we think, in the long run. But it's clearly nothing anywhere near that looks like El Nino at all. And then finally, sea surface temperature anomalies for the entire Pacific Ocean. But we really are interested. So this area here is called Nino 1.2. Off of Peru, Ecuador. And then the official El Nino monitoring region is right here, the Nino 3.4 region out here. You can see it's yellows and oranges, so warmer than normal, but not very much warmer. In the Nino 1.2 region, we'd say it's probably cooler than normal, approaching normal, but not quite there. When you have cooler than normal temperatures, that supports high pressure north of that area. So there's California, there's your extent of your cooler waters. So the wall probably breaks right off the California coast. Then east of there, it's warmer. So that's probably where all your moisture and storm activity would be, at least based on what we're seeing here. Actual sea surface temperature trend in the Nino 1.2 region. Hey, look at this. Today and yesterday, for the first time in a very, very long time, we're above normal by 0.2 of a degree, 0.263. Right there we are. But you can see how temperatures, it was even way back before August, have been way down below normal. They're kind of starting to wake up. This is pretty noisy, though. It's the official Nino 3.4 region that really matters. Here we are. Today's value plus 3.29 right there. But the trend has been definitely upward since August. We've seen that on all the charts. None of this is surprise, but to get to El Nino, you have to be half a degree above normal for 5 consecutive months. We're not even at half a degree, much less half a degree for 5 consecutive months. So basically, officially, we're in ENSO neutral. Not El Nino, not La Nina. But clearly the pattern smells locally in California like La Nina. And across the whole Pacific Ocean, it smells certainly not like El Nino. It's pretty weak, and you look at the weak MJO, and we say you need a stronger MJO pattern to get better storm production. All of this just sort of smells like we're kind of in this funk. We think all of it's driven by those easterly anomalies that are just locked over the Indian Ocean, blocking storm or blocking energy from moving east, into the Pacific Ocean. So you just we're in a funk, basically. But these things happen. You can't have it great all the time, unfortunately. One last data point. What's going on in the atmosphere above the ocean? Southern Oscillation Index, difference of pressure between Darwin, Australia, and Tahiti. When you have lower pressure over Tahiti, that's sort of what smells like the active phase of the MJO. If it sits there long enough, then by long enough, we're talking, months, then we're talking maybe El Nino. The daily contribution today, minus 9.17. Just scanning down here, the index has been, generally negative. Doesn't look like a strong negative trend daily. Let's go look at the 30-day average, minus 5.97. Going back in time, what's it been? Past month, anywhere from 2.5 to 5. So if we're in the active phase, it's not a strong active phase. It's just barely there. Yeah, from a month ago, yeah, we gained 2 points or something. That's nothing. 90-day average. Okay, for El Nino, this needs to be down at minus 12 or 15. We're at minus 8.53. So the atmosphere still is biased, even as we're a month away from the start of winter, still biased towards El Nino. Clearly no sign of La Nina, but we've got all this other, just the jet stream, you can count the number of swells we've had this fall. Clearly we're behind normal. So yeah, though this index looks like a weak El Nino, or not even that, but just a bias towards El Nino, and there's other data that looks that way, the objective evidence based on actual storm formation does not suggest that at all. It suggests the exact opposite. So we're in this kind of mixed, funky pattern. We think if that blocking pattern wasn't over India, we'd probably be in a pretty good position. We would have had a lot of storms by now, and the potential for rainfall into California would be really good. But we're thinking the blocking pattern over the Indian Ocean is just raining on our parade in a very bad way. So real long-term, quick look, what's going on the rest of the winter? Sea surface temperature Nino 3.4, the official El Nino monitoring region. Forecast, and this is pretty consistent with, there's like 15 different models, but they all are toggling around this outcome. That is, where are we? We're in November, so we're about here. Temperatures, this says 0.4 above normal. I think we're at 0.3, we said, something like that. And the general trend is hovering right around in there for the foreseeable future, and maybe going to neutral in August 1 of next year. But this kind of smells, again, like that PDO thing where the atmosphere in the Pacific is kind of primed to support El Nino. If it weren't for the easterly anomaly thing over the Indian Ocean, which is completely unrelated, we'd probably have a pretty decent winter going on. But it's just getting stomped on. There's nothing we can do about it. We're in this blocked kind of pattern, and it's going to do what it's going to do. Current data, you saw it yourselves, doesn't suggest it becoming unblocked till maybe early February, and by then, it's too late for winter. All right, so the quick recap. All right, we've had one swell. Nothing great, but we had swell, and it looks like there's a couple more gales forecast for the next week. Swell certainly to come from that. A bit of wind swell for California midweek, but that's supposed to settle out by Friday, and that's about the time that theoretically more swell would arrive the coast, so take what you can get. Beyond that, hard to say. Probably based on the MJO, it looks like the MJO is turning inactive. Things will start settling down. That's not to say there won't be surf, but it just won't be larger surf. It'll be small waves, barely rideable, probably starting around in the Thanksgiving time frame. But then, looking as we move towards Christmas, maybe a little bit improving pattern with the inactive phase moving out of the picture, and we just sort of go into a neutral pattern. But certainly, as we get towards the February time frame, if those easterly anomalies move over the Pacific, that will pretty much stomp on any storm production. But that's just a guess. The models change week by week. We don't believe a model even 5 days into the future, much less 3 months out. So take that all with a grain of salt. But the strategy for right now is, if there's waves, go get it. Pray for rain. Pray for snow. And if we don't get that, pay for an airline ticket to go north. All right, that's it for this week. If you enjoyed the video, hit the like button down below. You can subscribe. There's a little subscribe button. You send them your email address. You'll get notification every time we update this. Comments always welcome. Go ahead and type them out. We'll respond pretty quickly. We try. Sometimes it's a day off or so. Anyway, thanks for watching. Glad you enjoyed this. We'll do it again next week, same time. Thanks.